so here we've got a problem with a helicopter. So there's 3 forces acting on it, and the first thing we need to do is to label those forces. So force C, perhaps the first one, you can see it's acting directly downwards, so that must be the weight. Okay, now I would not write gravity on that one because gravity is a field, not a force. You could write the force due to gravity, but I prefer to write weight. And then this force A here, you can see here's the rotors, the helicopter rotors, which are slightly angled forward instead of vertically. And you can see that they are producing this force here, A, and that's the lift due to the helicopter rotors. And then because it's angled slightly forward, the helicopter is going to move forwards, and then you've got this resistive force B here due to air resistance, which we will call drag. Okay, so there's your 3 forces. Now the next thing, it says calculate the weight of the helicopter. Okay, so there's a couple of ways of doing this. I'll show you one way in this video and I'll show you another way afterwards in a different video. So the first thing here is we know basically that this helicopter is traveling at a constant speed, and from GCSE you'll know that if a object is traveling at a constant speed, then the forces acting on it must be balanced, and that is to say that there is 0 resultant force. Now, if we take, that means that if we take the forces that act on this object and we put them into a vector triangle, you will see that the vector triangle will indicate that there's no resultant force. So I'll explain that now. So let's take the drag force. Drag force is acting to the right. Okay, and then when we put vectors like this or forces like this into a triangle, we put them head to tail. So we're going to put the weight next, the tail of the weight acting downwards like that. Okay, so that's your drag, your weight. So we can call that force B, force C. And then force A is going to complete the triangle, and it's going to be a closed triangle, okay, because there is no resultant force. So we know that because there's no resultant force, the 3 vectors in a triangle will form a closed triangle, indicating that there is no resultant force. So we know that this force A here is 9.5 kilonewtons, okay, so that's force A, 9.5 kilonewtons, and it asks us to work out the weight. So the weight here is C, okay. Now we know that the angle between this lift force and the horizontal is 74 degrees. So the angle between the lift force and the horizontal is 74 degrees. So we now have a triangle, we know the hypotenuse, we don't know the adjacent, and we don't know the opposite, but we're trying to work out the opposite, which is the weight, okay? So if we know the hypotenuse, we want to work out the opposite, we're going to work it out using sine theta equals opposite over hypotenuse. So that is to say that sine of 74 is equal to opposite over 9.5, and therefore this force C here, this weight, is going to be equal to 9.5, because we take that over that side there, multiplied by sine 74, okay? And if we put that into our calculator, we're going to get 9.5 sine 74, which equals 9.1 kilonewtons. And the reason we're doing that to 2 significant figures is because our data in the question is to 2 significant figures. All right, so that's that one done. Now you could work out the drag from this method as well, and if you wanted to work out the drag, you know the hypotenuse, you don't know the adjacent, so you could use cos theta. So to work out the drag B, we know that cos of 74 is going to be equal to the adjacent, which is force B, divided by 9.5, and therefore B, okay, if I draw that there, B is equal to 9.5 sine 74. Sorry, not sine 74, cos 74. Okay, so 9.5 cos 74, which is going to give you 2.6 kilonewtons. Okay, so 9.5 cos 74, 2.6 kilonewtons. And that's that one done.